solve the following trigonometric equations. So this is the first equation that we have here. So we have 1 plus. So we have 1 plus cos 2 theta here equal to cos theta there. So what we're going to do here is we find the identities for cos 2 theta there, then we make a substitution. So now here we know that cos 2 theta here is a double angle identity, so and it has 3 identities there. So we have cos 2 theta here, so you can just say since cos 2 theta is simply equal to cos squared theta minus sine squared theta like this. Then the other identity is 2 cos squared theta minus 1, and also we have 1 minus 2 sine squared theta like this. So then what we're simply just going to do here is we pick an identity here that will make it easy for us to solve this equation that we have this here. So let's pick this one here. So then we make that substitution with that same one. So then we have 1 plus, where there's cos 2 theta, we're going to substitute with this identity that we have there. So 1 plus 2 cos squared theta minus 1 is equal to cos theta like this here. So then 1 minus 1, we're simply going to have 2 cos squared theta equal to cos theta like this here. So then here we don't make a mistake of cancelling out the cos and cos this side. So instead we get this cos theta that we have this side, we push it to the left hand side here, then it becomes a negative. So then we have 2 cos squared theta minus cos theta here equal to 0 like this here. So let me just scroll down a bit. So then here we factor out cos theta. So if we factor out cos theta, then you are left with 2 cos theta minus 1 equal to 0 then. So then what we do here is exactly the same thing that we do when we're solving our equations. We equate this cos theta here to 0, we solve for that, we solve for theta from there, and we also equate 2 cos theta minus 1 to 0, and we also solve for theta there. So then here we have our 2, or we have our cos theta equal to 0 this side, and also we have our 2 cos theta there minus 1 equal to 0 like this here. So then this side, solving for theta here, we're going to say theta is equal to cos inverse of 0, and then cos inverse of 0 here will give us 90 there. So then we get a 90 degrees. Then also the other solution that we want there is going to be 270 degrees like this here. Okay, so then this side we solve this equation as well here. So meaning that we can push the negative 1 the other side of the equation, or the other side of the equal sign, so that it becomes positive. So we're going to have 2 cos theta equal to 1, then we divide by 2 here. We divide by 2 then, so we have our cos theta being equal to 0.5 here, positive 0.5. So now it is at this point here where we have to determine in which quadrants our solutions for theta are going to come from there. So now cos theta here is being equated to 0.5, which is a positive value that we have here. So then when we remember the concept of quadrants here, we have this. So we not say all are positive in the first quadrant, then we just have the sine function which is positive in the second quadrant, we have the tangent function positive in the third quadrant, and we have the cosine function positive in the fourth quadrant here. So meaning that if this cosine function that we have here is being equated to a positive number, then our solutions for theta are going to come from the quadrants where this function is positive. So meaning that here the cosine function is positive in the fourth quadrant and the first quadrant here. So let's go ahead and solve for theta then. So then theta here will be equal to cos inverse of 0.5. So when we use the unit circle, you notice that cos inverse of 0.5 is just going to be 60 degrees here. So here theta here is equal to 60 degrees. So now we check if this 60 degrees is part of the solutions. Of course we know that 60 degrees falls in between 0 degrees and 90 degrees here. So meaning that it falls in the first quadrant, and cosine function is positive in the first quadrant, meaning making this 60 degrees part of the solutions there. So now, how do we get the other solution? The fourth quadrant here. So to get a solution from the fourth quadrant there, so we're simply going to say theta there will be equal to 360 degrees minus the calculated angle that we found here, which is 60. So this will just simply give us 300 degrees like this here. So therefore, the solutions to the equation that we're looking at, so we can just say therefore theta is equal to 60 degrees, 90 degrees, 270 degrees, and lastly 300 degrees like this. Okay, let's look at the next question.